Hello, my third grade class. Mr. Friedman here, and today we're going to be diving into the inverses of math, and we're also going to be solving problems that you have to do all four operations for. We got a pretty mammoth problem right here that right now looks really challenging, but by the end of this, you guys are going to be professionals, and it's going to be super easy. So, we're going to start off, we're going to look at a problem, and we're going to do A, and write A, math, alphabet. Doesn't really make sense, but by the end of this, you guys will know. We're going to do A plus 2 equals 6. All right. So you're probably thinking to yourself, how am I going to figure what A is? And that's where this fun word inverse comes into play. And I got a little riddle for you guys to help you remember. To find the variable, take the inverse of what is available. So addition and subtraction are inverses of each other. So what do you think we're going to do? If we're going to take the inverse of this, what do you think we're going to do? Subtract. So we're going to subtract. What are we going to subtract? Are we going to subtract the A? No, yeah, you're right. We're going to subtract the 2. But if we did it to this side, we also got to do it to this side. So then it's going to set up the problem. A equals 4. Yep, you are correct. So that is the first insight of you guys using inverses through math. All right, so we'll do another relatively simple equation, and then we're going to go tackle this behemoth. Mammoth. All right, so let's do. So we did addition. How about we do a subtraction? So we're going to use that cheeky little alphabet letter again. Minus. We got a number out there. We got a number. 1 to 4. Perfect. 4 equals. What you want? 8. Okay. So if for addition we did subtraction, what do you think we're going to do for subtraction? Addition, yes, correct, because it's the inverse. So we're plussing, but what are we plussing? We're plussing 4. Good job, y'all. Good job. Then do whatever you do to one side, you got to do the other. Right. So A plus 4 equals 12. Good job. All right. So it's time to tackle the beast. And for this one, it's going to be a little bit tricky because you remember last week's lesson when we kind of learned how to long divide? We might have to tackle some long division in this next problem. So let's take it. We got 9 times A equals 108. So you're probably like, but Mr. Peterman, we only did subtraction and addition. Well, if you think that subtraction and addition are inverses of each other, what do you think the inverse of multiplication is? Division. Yeah, you were definitely correct. So again, are we going to divide the A? No, why would we divide the A? We're trying to find what the A is. So we're going to do divide, what are we divided by? 9, correct, good job. And then, oh wow, 108 divided by 9? That's a tricky one. So I think we should use all of our operations to help us figure out what A equals. So we're going to set this up in our long division, just like we did last week, y'all. So what's our first step in long division? Correct, see if 9 can go into 1. But can 9 go into 1? No. So what do we got to do? We got to move to the second place. Yeah, good. Yep. So we got 9. How many times can 9 go into 10? 1 time. Good job. What's our next step, y'all? Multiplication? What are we multiplying them? The top by 9? Yeah, so 1 times 9 is what? 9, yep. Good job. And then you got to remember that we got to subtract these numbers, right? So 10 minus 9 is correct, 1. But then Are we done here? No? What do we gotta do next? Bring it down. Bring what down? The 8? Good job. What are we done here? Nope. Man, you guys are so smart. You guys are tricked. You guys are fooling me. So how many times can 9 go into 18? 2? Oh. And then we multiply top number by that number. Get another 18. And then we also have to subtract again, and that equals 0. So you remember that if that equals 0, the remainder is going to be 0. So therefore, remainder equals 0. And now, what does this 12 mean? Right, so A equals 12. You guys just tackled a really big inverse problem using all of the operations that we have been reviewing over this unit. Give yourself a round of applause.